So if none of you know me, I'm Lewis Bench. I'm an independent developer. I work quite closely with the Microsoft EPE guys and the Nokia guys. I've traveled around Australia, New Zealand, the US, training people on Windows 8 and specifically the Windows 8 side of device integration and some of the Windows Phone stuff as well. I'm one of these people that like to buy things and hide it from my wife, and I go off and go onto Amazon and look to see what new gadgets are coming out. Kickstarter is my favorite new addiction, and ordering a whole load of stuff. And I just like seeing how I can tie things together and start doing all these mashups with USB devices and Bluetooth devices and things like that. So this kind of stuff is my passion, and it kind of follows on into my job with where I work primarily with Windows 8, Windows Phone stuff, and I try to tackle a lot of the harder projects that come up in the Microsoft and Nokia camps. So I'm going to talk to you today about Windows 8, or particularly Windows 8.1, and the changes we're going to see from the talk I done last year. If you didn't come to the talk I done last year and you haven't really seen device integration into Windows 8, we've still got a whole load of other stuff that we have done, and I highly advise you to go onto channel 9, download either my session, or if you get bored of my voice, some of the stuff from Bill's, because all the stuff I talked about last year still exists. It's still there and we can still use it. This is just building up on that ecosystem. Let me find my clicker and I'll get started on my slides. So I'm going to talk mainly from a consumer perspective around how some of these experiences play out. This stuff heavily applies to enterprise, especially now we have Windows 8 embedded is now in the market, and that's getting the 8.1 refresh exactly the same as Windows RT and Windows 8 is. So it means that everything I'm talking about in terms of all the devices on stage, you can apply them to an embedded scenario. You can build out kiosks and all that type of embedded stuff. Also in terms of some of the enterprise development, point of sale and stuff like that, there's so many changes, I just can't fit them all into one slide deck. But to make it fun and entertaining, we're going to talk consumer. And specifically, because it's a Microsoft slide deck, we're going to talk about the Ramirez family. And exactly how the Ramirez family are going to be changing their mobile habits over the course of the next year because of the evolution of this connected device ecosystem that's being produced, not only by Microsoft, but across our whole entire industry, and how people's homes are generally starting to change with the advent of these new devices. So these scenarios, I think, oh no, sorry, there's not a third one. So Ramirez family, we've got Will, who's an architect, so he's a professional, mobile professional, roaming around, doing his thing, seeing clients. Uses obviously a tablet, being a Surface. Sarah is a real estate agent. She goes out, does similar kind of things, roaming about, seeing clients, uses cameras quite a lot. And they've got a teenage son, Toby, as well. So over the next year or so, likely scenarios that we're going to start to see from them, Will wants to go online and buy a toy for Toby. But instead of actually going online, filling all the details out and stuff like that, we're going to start to see a lot more information persisted to the cloud and utilizing the devices that are starting to be built into the device. So specifically in this instance, we've now got NFC, so it's all probable we could actually start tapping cards on the back of the tablet, receiving the credit card information and passing it up securely onto the internet. Also, as you'd have seen out in the showcase, 3D printing is now here. Like, we've had 3D printers for a while. I actually had one at an event in Sydney a couple of years ago. The price point was still fairly high. And it was also fairly difficult. You had to be a pretty good Python developer because a lot of the driver stacks were just expecting raw print information to be fed in, and you was having to kind of generate 3D meshes in Python and then pipe it directly to a printer port. Now Windows supports it. It just recognizes as a printer in 8.1. You'll go in and you'll have your HP inkjet and you'll have your MakerBot. And depending on what you're printing, you can print it in 2D or you can print it in 3D. The price point of these now start at $500, and we're gradually seeing them fall every 6 months or so. So in the US, you can now walk into their equivalent of an office work, so a Best Buy or something like that, and you can go and buy a 3D printer. And people ask, well, what do you want to do with a 3D printer? Well, there's actually several use cases where people have gone out, washing machine's broken or something's broken on a device in the kitchen. You can either go and buy the part from the manufacturer for $500, $600, or you can go online, download the CAD files, stick it through the printer and print it for $3. And it's a viable part. It's a plastic, ruggedized piece of equipment, works really well. And it's actually being used quite regularly in the US and Europe at the moment. So they're the types of things we're starting to see with this development of the household of the consumer ecosystem. So specifically, we get some new scenarios we're starting to see within Windows 8.1, things that we couldn't do in Windows 8. Like I was here and I spouted everything we had good in Windows 8 about devices last year. We had loads, we had sensors, we had camera access, we had AR stuff, we had sound stuff. But there was limitations, and if any of you have tried to play with these APIs over the last year, you most probably kind of run into the same frustrations I did, especially if you're an enterprise developer, of you got to a certain point and then you stopped. This has got better. It's still not great. I've spoken to a few people that have kind of run into the barriers, but we're a hell of a long way further along the lines now in 8.1, and we're certainly a lot further down the route than we ever was in .NET in terms of being able to interact with particular devices. And specifically on 8.1, these are scenarios that are now specific to Surface, Surface RT, them types of devices. When you're roaming around, you can now have your agenda show up when you arrive at a customer location. We can use a piece of technology called geofencing that's now been added into Windows 8.1 to get the operating system to tell us when you move into a specific geographical location to send an alert or to launch an app or to do something. So we've got enhanced geolocation to the point of we know which satellite is relaying that information. So we're getting more information from these APIs. We're also getting access to Bluetooth. Bluetooth support was always in Windows 8. It's always been in Windows 7. It's been in Windows XP for a while as well. And the difficult part was, as a developer, we didn't have managed access to it. We could write custom drivers, and as an OEM, we could then write a WinRT component in native code that routed through to the driver and tried to communicate with it. But it was very, very difficult. That's now changed in 8.1, and we have a managed API, which can be used in JavaScript, it can be used in C#, or it can be used in C++ to talk to Bluetooth 2 and Bluetooth 4 devices. Opens up a whole new world of experiences for things like Fitbit, and all these other peripheral devices that we're starting to see people wear as well. The last one I'm going to talk about today is USB. There's still hundreds of thousands of USB devices in the ecosystem, and one of the unique propositions of the Windows tablets is we still have USB ports on the devices. So things like Surface, Surface RT, even like these ASUS Vivo tabs that have the same form factor as an iPad still allow me to plug USB devices in. And now as developers, we have access to the USB devices and been able to access and control them. So Windows 8.1 provides the new opportunities to build compelling apps, connected devices across desktops, laptops, and tablets. If you was in Vaughn's session where we kind of screwed up the demos yesterday, at the lunchtime sponsor session, we were trying to emphasize mashing up these types of scenarios, looking at your smart TV and getting it connected to your wristwatch and things like that. Windows 8 is a platform that enables that, and it's one of the best development platforms around to actually help with that, providing managed APIs directly into the devices. So I've got a couple of things on stage, and I'm going to run through each of them in different demos. But the first thing I wanted to show was actually how the 8.1 proposition it has evolved in terms of the way OEMs are actually thinking about devices as well. So I'm sure plenty of you have walked past the showcase and have seen me walk around with this nice little device here. So 8.1 has changed the way Lenovo thought about home PCs. So they wanted to actually make it more engaging, and they saw how children were interacting with tablets, and they were going off and playing games and things like that. And it was a very isolated experience. But a home PC should be a social experience. It should be the hub and aggregation of all your media and experiences, and you should be able to share that with people. So Lenovo built this device called the Horizon, which is a i7, 8 GB of RAM, has a fairly chunky hard drive in it. And it's a nice looking all-in-one. Quite happily have it on my desk at home, run Visual Studio, stuff like that. Where they thought it was clever is they actually put battery in it. So it's a tablet. So I can actually turn it on, and it's completely wireless. So it's on at the moment. I'm running Windows 8.1 on it, and it's all working fine. Okay, great. So we have this big chunky device that we can carry around. And I have carried it around office blocks and gone into meetings with it. It's great because it's got HDMI in, so I can use it as a mobile display if I want to. But in the household, to kind of have this social conversation with my kids, and I want to interact with my kids, so I don't want to just give them my iPad and they run off. I want to be able to go to my dining room table and lay it completely flat and actually start playing a board game with them. So we want to actually play Monopoly. I'm trying not to pull the tablecloth off the table. So we now have this experience. You can't see what I'm doing, but we've now got this touch experience where I can start moving things around on the screen, and we can play board games and stuff like that. So yeah, we could have done this with 8.1 with Windows 8. That's all great. We could have done it with Monopoly Set, yeah. But then we couldn't have stuck it on Facebook with our scores and stuff like that.
You got me.
But where Lenovo decided to one-up themselves is leveraging the new device APIs we have in 8.1, is they built a Bluetooth device. So when we play Monopoly with our kids, we don't just roll the dice and then we manually tell the app what we're doing. We actually roll the dice and the app says, you've rolled a 4, and it actually moves things on the wheel 4. So it's a great little device, and it just kind of shows where people's minds are. Like that, there's a lot of negativity around what's happening in the WinRT space and the modern apps and things like that. But progressively, people are trying to understand and they're understanding the experience, and they're kind of moving on in the way we're interacting with these devices and building whole new experiences that a couple of years ago we kind of never expected would have existed. Or if you looked at the Samsung SUR40, the classic Surface, the big tabletop, would have cost $11,000. This device was released in the US in June, and it's listed at $1,500 US. So it's an affordable home PC, and we're talking about this next generation of connected experiences, tabletop PCs coming to reality in the home. But however, I don't work for Lenovo, so I don't want to keep selling the device to you. I'm actually going to move on to something I'm here to talk about. So this is what I'm going to cover. The Windows 8.1 enhancements. We're going to try and do it as quickly as possible. I've got 4 demos. I don't know whether I'm going to get through all of them. I've got 5 demos, actually. I'm going to then talk about how the user experience has changed in terms of what it's going to look like in terms of an OEM interacting and you as app developers and how that works. And I'm going to try and show you some of the code and how easy it is to start interacting with devices. There's always been a barrier before, and people got scared of if someone said, hey, let's go and buy a device and you can write me an app for it. There was this barrier of entry of people didn't really understand it. It's now really, really easy, and I want to try and advocate people go home, have a look around the house, see what they can plug in and start writing apps for it, because it's really fun. So before I started waffling, you'd have heard me talk about Will and his specific scenario of going around to houses and geo-fencing and all this kind of stuff. So let's actually look at some of the things that enable Will to actually now improve on his business scenarios and his job and make his life a little bit easier. And some of the changes specifically in 8.1. So first one we have the biometrics frameworks that existed in Win32 ported across to WinRT. So that means we can now support any type of fingerprint scanners and things like that on the devices. We can access them via a managed namespace, windows.devices.authentication.biometrics. All the APIs I'll mention to you today follow very, very similar routes. You would have caught onto this last year if you was here last year with me. It's literally an async call to a device. You get a device, you get a socket, you start passing information backwards and forwards. You just need to remember the namespaces. But great, we got fingerprints. We've also got smart cards in the enterprise space, so that's a little bit further down. So if you're doing anything with enterprise apps, we've got the full smart card framework that was available in .NET or ported across to .NET, was originally a Win32 API, now exposed into WinRT, which is great. So you can do virtual smart cards for direct access, authentication into apps. You can do physical smart cards, so you can log on to apps and stuff with the smart cards. This is also an API that allows you to access smart card devices to accept credit cards. So we have NFC in terms of proximity and communication, which I'll talk about in my session tomorrow, but we also have smart cards that allow us to read the credit card information. We've had POS.NET ported across to WinRT as well. So if you do anything with point of sale, point of service peripherals, so barcode scanners, magnetic stripe readers, receipt printers, docket printers, any kind of POS peripheral, now just a managed API. Again, exactly the same connectivity method. I've already spoken briefly about geofencing. We've had a whole load of additions to the imaging library as well. We now support scanners in a consistent interface, yay, because we haven't ever had that before. If you can still find a scanner somewhere, I actually really struggled to find one to demo, which is why I don't have one with me, because they're still like $400 or $500 in Officeworks, because no one buys them anymore. So it's really difficult to try and hold of them. But if you do have a use for a scanner, if you've got enterprise apps that you want to use scanners and Twain drivers, they're all available to use as well. And there's a whole load more as well. Loads and loads of changes, but these are some of the key ones in terms of enterprise scenarios. So Toby and Sarah, so moving away from enterprise, the consumer interactions, as I mentioned before, we've now got a couple of extra additions that allow us to build apps specifically governed around the devices themselves. So in Toby's case, he bought the toy on the internet, he bought this little USB missile launcher, and we can now start writing an app specifically around driving the USB missile launcher. We have Bluetooth connectivity, so Bluetooth 4, specifically the RF COM technology, and the demonstration I'm going to use here is a serial port profile, so it means that we can start actually driving devices like my little Sphero ball here, Pebble watches, TVs, most of these devices, most of the Bluetooth devices you have in your home use this protocol. The newer devices, however, are Bluetooth 4 devices. So the devices you have on your wrist, devices you use in the gym, and some of the new finance type devices like credit card readers and stuff like that are Bluetooth 4. Bluetooth 4 is a low energy technology, so it means the devices last a lot longer. They run on watch batteries. So we have full support for that as well. And what this is enabling is app developers and hardware developers to start syncing up a lot easier and create compelling experiences. Sorry, I've got a few more slides, and then I'll jump into some demos to try and explain some of this stuff. So the way this now works is before, if we was ever developing if we was ever developing for a particular device protocol, so like a HID device, a USB device, a Bluetooth device, we would have actually had to talk directly to Win32 APIs. And if you was a .NET developer, you would have been doing this via pinvoke and some marshalling backwards and forwards of objects. There were some great libraries that eventually appeared, like WinUSB, but they were still fairly limited and they weren't supported by Microsoft. So if Microsoft changed anything, it became difficult. And this meant for a lot of these devices, so the USB rocket launchers and things like that, you would get the OEM to write a device, they'd write a driver, they'd write an app, and then it would just stay there. You would never be able to interact with it. It became too hard for us to kind of mash this stuff up. And the same with Bluetooth as well. Like, everyone has Bluetooth on their computer, but I bet no one's ever written an app for it because .NET never had an API. It didn't exist. No one really ported it across. So again, you'd have to have gone back into Win32, became difficult. You were dealing with a whole load of stuff you didn't want to deal with. So it meant that the ecosystem around Windows apps, talking to peripheral devices, was left to the hardware developers and not the app developers, not the people that were writing the enterprise stuff. So it became a very niche market. We're hoping to bring that back again. What this slide is trying to represent is the way WinRT changes this is because of the way WinRT is architected, we get the app can talk to the API. The API is a bridge over COM, so it's actually just talking straight to the drivers. It's baked into the operating system and just exposing that directly in a nice managed API for us. We're going to jump through some of these slides just to move a little bit quicker. So where we're actually looking at this, as I say, is a lot of this is driven from the Kickstarter ecosystem. We're seeing a lot more stuff arrive that we want to try and integrate into, like the Pebbles of the world. This stuff is a great example, and we want to try and make sure that they're appearing on our tablets. So let's jump into some code to make it a little bit more interesting. Okay, so as you'll see on my stage, I've got two different USB devices. So I have this one here, which is it's just a USB rocket launcher. I picked this one up from Australian Geographic. It's like a $30 toy, one of these gimmicks that you normally buy people at Christmas, and it comes with a little app, and you install it, and you fire at a few people in the office, and it goes in your drawer, and you never see it again. This other one here, this is actually a kid's toy, believe it or not. It comes as a kit. You build it yourself. It's by a company called the OWI. It's a $60 robot arm, all made of plastic, and you have to cut all the cogs out and create it and stuff. The reason I got two USB devices is because to Windows, they actually represent themselves in two different forms. This one here is actually a HID input, so a human interface device. It's the same driver stack that keyboards and mice use. The reason that's significant, it's a standard Windows driver that means it will work on an ARM device because Windows and Microsoft specifically have obviously ported all of those drivers across to WinRT running on ARM. The manufacturer doesn't need to worry about writing their own driver. It just uses existing Windows stuff, so you can plug it into a Surface RT, it'll recognize it. This one, however, because it's actually a robotics kit, the driver that came with it was unsigned. And I really struggled with this. It took me a week to pull this demo together. Because it's an unsigned driver, normally to use it, you have to boot into like advanced mode in Windows and turn off all the security settings to allow yourself to use unsigned drivers and things like that. Where this has changed in Windows 8 is we can actually now use a generic USB driver to drive USB devices as long as they conform to the USB standard. Luckily, this one does. So what I've actually done is instead of it appearing as an unknown device in my device manager, I've actually got down here now a new category called Universal Serial Bus Devices. So this is how devices would normally see themselves. They'd expose as a USB hub or a controller. This is a device using the WinUSB driver. And the WinUSB driver is a new driver that came out in Windows 8 and now has been involved with Windows 8.1. And for us to be able to interact with a USB device, the device needs to have derived from this WinUSB driver. It means it conforms to it conforms to WinRT and it conforms to all the APIs to allow us to control it. So I can now actually jump into my code and I'll actually quickly run it for you. So this is my robot arm code. I'm a XAML developer, so I'm going to show you everything in C# XAML. But again, I'll emphasize you can do this in JavaScript if you really want to do it in JavaScript. I don't know why you'd want to do it in JavaScript. You can do it in C++ as well. Again, I don't know why, because C# is great and I love it. But I'm also not a user interface developer. The reason I work with devices so much is I hated CSS and HTML, so I moved across to just writing code. So please excuse the ugliness of my demos, and I do understand the whole MVVM framework model, but just to make things simpler, I've just stuck it all in code behind. So what we've got here, just a standard file, new blank Windows 8.1 project.
Can you zoom in?
Yep, I will do in a sec. I'm just going to show some other bits and then I'll zoom. So, yeah, file, new project, blank page, and I've just got an image dropped into the XAML just to make it look a bit more interesting. The first thing we end up having to do with this robot arm, as you'll remember, if you came to my previous sessions, we have to actually specifically ask permission to start using devices. Windows RT is a sandbox environment. We can't just start saying, hey, let's go and access your NFC reader and your geolocation and start pushing all this information up to the internet. Obviously, there's going to be a whole load of privacy concerns around that, and there's going to be a whole load of security vulnerabilities as well if we can now start saying any app in the store can access any hardware device attached to the machine. So we have to start adding things into the app manifest, and the difficulty is the app manifest has had to retain the original XML schema for the app manifest for Windows 8 devices, as well as add an extension into 8.1. So what we're having to do is actually edit the app manifest purely in an XML format to integrate with a lot of these devices. So I'm just going to jump into the app manifest, but I'm actually opening it up into the XML version, which hopefully you guys would have seen this in previous sessions before. I'm actually going to jump down to this bottom here, and you'll notice it's this M2 addition. This is actually using the additional XSD namespace declaration that's been provided into the app manifest for 8.1. So anything you see with M2 means that it's specific to a Windows 8.1 app. And specifically here, we have this device capability that's been declared. So this is an extension of the standard capabilities we had before, USB microphone, proximity, internet and client connectivity. We can now actually customize this a little bit and say, we want to access a specific device or specific range of devices on the machine. So every app I show you will now have this extension in. This one is specifically saying it wants to access a USB device, and it wants to access one that uses the vendor ID 1267, which is the manufacturer that that built this device, and the product ID, which is 0000, because it's an unsigned driver, it's just a generic product ID. And this type here, I've actually put the type in as a hex string, but it actually just means a vendor-specific device. So what you can actually do, if you don't want to say you're building an app for a robot arm made by this vendor, you can actually decide, whose birthday is it? Tommy Gower's birthday, everyone. We should wish him happy birthday. If you don't want to say we're writing a device for this specific, writing an app for this specific device, we can actually look at a range of devices. So if you're writing, say, a point-of-sale system, we can say allow access to any device registered within Windows as a point-of-sale device. So what we do is we play around with this device capability declaration, and the name would become point-of-sale, and then we would give the device ID as any vendor, so you can actually just use the word any, but the function and the type would be a particular type of device. So you would say point of sale, any manufacturer, but of type barcode reader. All of this.
How do you find the IDs?
just about to show you the ID part. I was just going to say all of this enumerations of what you can actually do with this is all on MSDN. MSDN is the Bible for this stuff at the moment, but you have to really look to kind of understand what's going on. Or the other way of doing it is you can actually jump into the XSD, and it's actually quite well documented in the XSD of what you're trying to push backwards and forwards. Doug's question was, how do you actually find the device IDs for the devices? So there's two ways of doing it. You can do it in Device Manager. So you can actually jump into Device Manager, right-click the device, go into Properties, and if you start looking in the details here, you'll find like your hardware ID. So you've got your vendor ID and your product ID. It's great on these types of devices, or generic devices, because they're quite well structured and you can find it really easy. If you get stuck, you can also download other utilities like USB View, and they actually enumerate it out slightly easier for you. So you can just see all the properties and you can just go through and say, oh, look, it's there and it's this device. I've also got a third app on here which I won't show. It's only a trial and I think it's about to expire. But it's actually like a port sniffer. So it'll actually show you all of the USB traffic that's happening on your machine. So if you can't figure out what device it is because you've got a couple of generic devices, you can actually start pushing operations through an existing app and then just look in the port sniffer to see what's actually going on and from which device signature. So now this is in, it's great. Means that when we launch the app, it'll actually pop up and say, hey, Lewis's app wants to use robotic arm. Would you like to allow it? Yes, no, as before, people can say no, they don't want to allow it, so you have to gracefully deal with that. If they say no and you then try and access the device, you're going to get a whole load of security exceptions. So make sure that when that permission's asked for, you're dealing with that scenario where if you can't access the device, you're going to have to display to the user the fact they need to ask permission for it. They can also revoke this permission at any time using the settings as well, because it is a privacy thing. So back into the code. So to access a USB device, I should have commented my code a little bit. Sorry for the scrolling. So this is how much code it takes me to then retrieve that device and open the socket to it. So the first line here, two constants. They should be constants anyway. They're not. I was lazy. Again, the vid and the PID, vendor ID, product ID. This is for me to actually specifically look up the device in the API and actually know I'm going to communicate to that specific device. This actually creates a query string, so it's actually just a string it's going to create using a helper class. And it's very similar to SQL, and all it's going to do is enumerate via the device manager and look for any devices that match this criteria. That vid and PID is passed into here, which is gets the AQS. The AQS is then pushed into windows.devices.enumeration. Again, if anyone was here last year, this is my favorite namespace for last year. Still is one of my favorite namespaces. There's a whole load of stuff around things that we can access in Device Manager. This one is specifically enumerating through, doing exactly what I've just done in Device Manager, looking through all of the device tree, and then it's going to basically retrieve all the properties for me. So I then get a device passed back. When that device is passed to me, I go to windows.devices.usb, and then I use the USB device object, and I say I want to be able to connect to a USB device using a particular ID. That ID was given to me by the previous command. It's actually part of the device object that's returned. So in this scenario, I know there's only one I know that there's only one device attached with that ID. But obviously, if you're developing a consumer app going into the store, you won't necessarily know this. So I'm just going to index 0, pass the ID in, and then I get my object back. That is all I need to do to then connect to that device. I've then got an open connection, an open socket to that USB device. All the heavy lifting is done for me by WinRT. I don't need to do anything else apart from start passing commands backwards and forwards. So this is all done on the loaded event of my page. I can then start saying I want to be able to set the light to true. I'll actually change the gripper to close because it's currently open. And then I can start moving the joints around on the robot arm. So to do this, all I'm going to start doing is actually passing USB control packets backwards and forwards to the robot arm. Robot arm is fairly well documented on the internet. A lot of people hack around with this particular device, so it's very easy for me to Google OWI, robot arm, USB controls, and people cleverer than me before have sat there, looked at all the drivers and said, well, to make the robot arm move around, you need to pass an 8-bit packet, and the first byte is controls the access, and it does this and this and this. But it was all documented, so I was able to figure it out in a couple of hours. So specifically, I have to set up a USB setup packet using a particular control type, saying it's a vendor-defined control. I'm passing the device out I'm passing the direction out, so it's actually going into the device, and it's going outwards into the device, because obviously USB is a two-way socket, so the device can talk back to me. In this instance, I'm only controlling it. I then pass in a couple of different bits of information around actually communicating. Again, all of this was just given to me from the internet. I didn't have to do anything. I just had to write some basic C# to wrap what was a Python script I was looking at the time. And then I'm just using this async method that's attached to the USB object I've already created, saying send control out transfer async. So I'm passing that piece of header information across, and then I'm actually passing the bytes in, which is the actual control to the robot arm. The equivalent of this is, if you're a web developer, imagine that big method that I've just spoken through really, really quickly as the HTTP header is telling the device a whole load of information about what's coming, and then it's actually sending the payload itself. So that's the only difference in USB. It's a very, very similar protocol to HTTP in that sense. So it sends it off, uses the greatness of C#5 async, so it'll actually write the buffer to the stream, it'll hit the stream, and then it'll actually call back, and then you can actually then start continuing. So nice little async method. That's it. That's all it takes for me to write to that robot arm. So now I can just go through and I can just start building a more managed API around that to say, set light on. I'm sending a couple of bytes across, which is 0, 0, which is light. I think it's light, and then the value of the light. So on and off, so 0, 0, 1, 0, 0, 0, and then that will actually toggle the LED. Similar to all the directional stuff, open and gripper, which means it's going to move this particular motor at the top here, and it's going to give it a time to actually move and then to retract. And then the joints as well. These are all just really basic servos. So the USB controller, all it's doing is just getting the information and looking to know which servo to activate and for how long. Which means the end result is not that impressive, but if I actually run the app, and my USB hub holds out, which is the other thing I'm worried about. So permission, explicit permission, saying it wants to ask, my app is called Robotic Arm, wants to access a WinUSB device. So WinUSB device is the name of that device in Device Manager. I'll allow it, move to turn the lights on. So nice and simple. I can trigger all them commands now from my interface. I was trying to pretend I was Tony Stark, so I was trying to style it up a bit nice. So I can now have this experience where I can put it on I'm going to have to use an Intel tablet for this because of the actual driver, but I can put it on something like the Acer W3 and actually have now a completely controlled touch experience. I actually wanted to go one up on myself and actually do a full-on voice recognition demo as well. And I wanted to pretend this was Jarvis from the Iron Man, and I wanted to start talking to the device. It's all possible in 8.1 because we actually have voice recognition coming, but unfortunately Bing haven't released the SDK for it yet. So as of 18th of October, there's no reason why you can't start talking to the computer and the computer will start moving your robot arm to build you Iron Man suits and things like that. Okay, so that's one demo. We can also do a similar thing to HID devices. HID devices are a little bit simpler, mainly because they don't require the control packets. So we're doing exactly the same thing here. We have a vid and a PID, and a couple of other bits of information specifically written to a HID device. But because it's a generic driver, we only have to send the payload across to it. So what we actually do is we go through exactly the same process. We create this AQS string up, this query string to go into Device Manager and say, get me devices based on what I'm looking for. Again, I'm specifically saying this manufacturer, this device. I get in this instance, I'm getting something called a device watcher back. So I didn't explain this properly in the last part, but there's two ways of actually creating the device. You can actually specifically get a device collection back and say, all of the devices connected to the machine at this moment in time, and I want to go to a specific index based on that collection. Or you can use a watcher, which monitors essentially the device manager, and any time a device is plugged in or removed, it'll raise an event. So this means that asynchronously, you can have devices added and removed to your tablet, and then your app can recognize that a device has been added, and you can start controlling it. So this instance here, I'm getting that AQS string, I'm passing it into a device watcher, and now I'm just waiting for the device watcher to say, yep, there's definitely a device there. It raises an added event. And then I'm actually, again, instantiating that device. So another going into windows.devices.hidDevice, so, or human interface device.hidDevice, and I'm using the from ID async, so exactly the same command that I was using for that USB device before. And I'm just saying, passing an extra parameter into set, it's a read-write connection to a HID device, mainly because HID devices are normally read-only, because it's like they read in keyboard commands or mouse commands. And then this one's even easier. I just pass it byte message, byte array backwards and forwards. Because HID is such a simple input, it's just passing normally a mouse position or keyboard commands in and out. It's very, very basic payloads. All I need to do is actually pass the byte array representation of up arrow, down arrow, left arrow, right arrow, and that will actually start controlling the missile launcher. So I just passed that back in. I'm using a data writer to actually pass that information in, and then just using that send output report async, which is here, to then write back to the missile launcher. So I know I'm going through this code really, really fast. I'm going to push everything to GitHub just straight after this session, so you can pull the samples down and go through step by step. And all these devices are in the dev den, so if you actually want to come and just go through the code line by line and see how it interacts, it's all available there as well. So this one's going to be a bit dangerous. If I hit anyone in the eye, please don't sue me. So I'm going to run this again on my local machine. You'll have seen this one around as well. This is one of my favorite ones. So again, I'm not a designer. Please don't critique my look and feel of my apps. Again, explicit permission, they can approve or deny it. And because there's a device already attached, you'll see that the light came on because that's when the device watcher said the device was attached and it made that connection, instantiated that connection. Now I can actually start clicking on my buttons and my app crashes. Oh, there we go. Lucky you, it didn't hit you in the eye. But we can actually just start driving it around by passing. Well, some of it was bound to break in this demo. So if fires, which is just an enter key command, the directional arrows do work temperamentally, and it will actually pivot the turret around. It's been battered around in my bag today, so I don't know whether it's the turret or the actual app itself. But I have it on here, so again, it works on the WinRT device, so specifically this one. So I can plug it in here, and it will just work on the Surface RT. It's using a generic driver, nice and easy app to write. It takes away most of the heavy lifting for you. Like I say, these devices are $30 as well, so a great device to go and buy and play around with if you can get your hands on them. So I quickly flick back to my slides. So just a quick summary, like the API is simple device access. If you've done this stuff before in native code, this is a hell of a lot easier than where we was this time last year. And it's designed to be consistent with every other device API we have. I know some of the USB stuff can look complicated, but once you get your head around the fact it's just a header, and then you're just passing these byte arrays backwards and forwards, and then you're opening up a stream, and you're just reading and writing backwards and forwards, it's really no different to actually connecting to a lot of the stuff we have to on the internet, the complicated media streams and stuff like that. So it opens the doors up to developers, any developer, to start doing this stuff. If you're not that clued up on how streams work on WinRT, my session tomorrow, my Windows Phone session, I'm actually going to deep dive into network streams and actually talk about data reader and writer a little bit more. But yeah, this opens up all sorts of devices. So I just want to quickly show you Bluetooth, because Bluetooth, again, another interesting piece of technology. And a lot more devices aren't necessarily going to be on cable anymore. They're going to be the wireless devices, the robots of the world, the heart rate monitors and things like that. They're not going to need you connected to the tablet. So to do this, the first one I want to show you is Bluetooth 4. And I actually want to run the demo first, just to see if it is working, and because I want to get rid of the heart rate monitor that's strapped around my chest because it's starting to annoy me. Oh, is the screen not working? Because I pushed the wrong button. Actually, nope, sorry, I'll talk through the code because I haven't actually built a UI for this one. It's the other one that has a UI. So the code's identical to connect into a USB device, to connect into a HID device, to connect into a Bluetooth 4 device or a Bluetooth 2 device. We create a query string to say, we want to connect to a particular device. This one uses, again, a device watcher. We want to know when the device is connected to the machine. And then we open up a stream and we start passing information to it. Where this changes a little bit is Bluetooth 4 GATT protocol. Again, equating it to the web, I'm hoping here everyone's fairly familiar with web APIs. GATT protocol is very similar to SOAP. It has definitions and it has ways of expressing metadata in a structured format. Whereas Bluetooth 2 serial port profile is an open socket. You can pass information backwards and forwards. GATT information is always structured, and it's structured based on a unified way that machines know how to read it. That specifically means that we know for a fact that a heart rate monitor is going to expose a heart rate monitor contract, and it has a unique ID to say it is a heart rate monitor and it's exposed in that contract. So when we go and get the device selector, we can actually say get device selector from UUID. So the GATT API actually produces query string for us, and we just say what GATT device we want. And it's an enum. So if I open this ReSharper wants to think about it, you'll see all these different devices that supported just out of the box are just generic profiles that are agreed to by the Bluetooth special interest group. They're just standard contracts that you can subscribe to, which means any type of basically sport or personal fitness device will work with your apps, your Fitbits, your heart rate monitors, your biking accessories and things like that. You just got to think of a use of why you would connect them to a tablet or a PC. But they do just work. You don't need to worry about vendors and things like that with this one. It's a standard. So my one was specifically a heart rate monitor. And again, device watcher, exactly the same as what I was doing before. I'm waiting for the device to be connected to the machine, and then I'm going to try and open a connection. When a device is connected, this is an interesting one that I forgot to touch on last time. If you're using a device watcher to actually run, to watch the computer, to wait for devices to appear, you need to dispatch back to the UI thread to actually make the initial connection. The reason for this is because it has to pop up that little permission dialog, which obviously has to execute in the UI. I only found this out the hard way when I broke a demo because I wasn't dispatching on the UI thread, and it took me half a day to try and figure out why it was throwing a security exception. And this is why, because it wants to pop up a modal, it needs to be on the UI thread. So all I'm doing here is my device watcher has passed me an ID back, exactly the same as before. I'll zoom in a little bit more. And now this ID, because it's contract-based, we have something called GATT characteristics. So a heart rate monitor can tell me two different pieces of information. Firstly, my heart rate, and secondly, where the device is being placed on your body. So this one is strapped around my chest. Some you can put on your finger, some you can put on your wrist. But the device itself obviously knows what type of a device it is, so it'll expose that in the contract as well. So specifically, I'm asking for the characteristic of my device of what my current heart rate is, and then subscribing to another event to say, has that value changed? One of the reasons Bluetooth low energy is low energy based is it raises events. Like the API raises an event. So it's not a constant connection and you're not running a thread and constantly polling something. The device will tell you something has changed, you need to do something. So it's not maintaining this connection and streaming data nonstop. Once that changes, this event's raised, and I read it, process the data, and it will get my heart rate. So I don't think I have a UI because I was lazy with this demo. No. Okay, so all I'm going to do is put a breakpoint in, it'll connect to the device, it'll read my heart rate. That processed data is all it's doing is a little bit of parsing of the raw data that's coming back, and it's just giving me my heart rate. So I'll run it and see what it says. So it's connected, super fast connection. It didn't actually ask me the permission that time because I'd already paired it in the past, so I remembered that I'd already had permission to run the app. It was already installed on my machine. But if you actually have a look at this here, I've got no way of actually zooming into this, I don't think. Can people read that? I guess not. Does anyone know how I can zoom into it? No? Okay. So it says 110 beat.
Windows Plus.
Windows Plus. Oh, look at that. Learn something new every time at these events. How do I make it go into the middle? There we go. So it's reading my heart rate, 110 beats per minute, which I guess is a little bit higher. And then it's got a date time value, which is this device doesn't actually support. That event will be raised every couple of seconds, and then you can actually start plotting it on graphs and actually see what your heart rate is. If I then take the heart rate monitor off, it cuts the connection off, and it will start throwing an exception. It's actually nice to remove it from around my chest. But yeah, it's just a very, very small, easy-to-use device, runs on a battery, and yeah, it's a great, easy connection thing to use. And again, if you've got Fitbits and things like that, uses exactly the same API. So if you buy in these personal devices and you want to play around with them, you want to mash up the APIs, very, very easy to use. As I mentioned before, we also have Bluetooth 2. So you may have seen this thing rolling around the floor in the expo hall, little robotic ball I can control wirelessly. Bluetooth 2 is pretty good. It goes up to 10 meters or so away from me, and very, very fast and responsive. For the sake of time, I won't talk you through that demo because I've got a couple of more slides and another demo to go through. But this is exactly the same. Apart from it's not a defined contract. It's a serial port that's open. The actual profile within Bluetooth RF COM is called serial port profile. So it's no different from me plugging in an RS-232 serial device and passing that backwards and forwards to connect into this. Same kind of thing. But all we're doing is we're opening up a string, we're passing basic byte commands, very similar to this HID device here. So we're going to create an AQS string, we're going to go to a watcher, we're going to open the device up, and we're going to pass a byte array backwards and forwards. That will then control all the different devices in here. Because it's a serial port, it's a two-way thing. So this device can then start talking to me, and I can start talking to it. Which means Sphero is really great because I can make it roll around on the floor, start changing colors and things like that, but it can also tell me where it is and whether it's seen another Sphero. So we can use it for game inputs, or we can race each other and things like that, and there's a whole load of different uses for these little robotic type devices. One of the other biggest benefits of the fact that these things are wireless and Bluetooth is that they use generic Windows drivers. So they work on ARM devices. So my Asus, which is an ARM device, lasts me 12 hours, connects to this perfectly. This only lasts for 2 hours. I can sit and drive around the expo hall the whole day. I don't have to worry about recompiling my driver code to work on ARM and stuff like that. The generic Windows stuff, Microsoft does it for us. We just use the nice managed API to build the experience out. Again, all of this is in the dev den and the showcase, so if you want to look at the code or come and play around with the toys, they'll all be available after. Okay. So, new user experiences. You can actually, as an OEM, create companion applications, which means if you build your own hardware, or you take someone else's hardware and you get permission to build them an app and put it in the store, you can actually start registering within Windows, and you'll start to see these experiences change a little bit. So they're carrying on from what we usually expect when we plug a USB device or we plug printer and stuff like that in, like or phone. What would you like to do with this device? Would you like to open Explorer and things like that? But we can now start registering our apps against the signatures of the devices we're using. So that means if I connect a Sphero to my tablet, it will start popping up and say, hey, you've connected to Sphero. Would you like to use Lewis's app or Doug's app or someone else's app? Because these are the apps that are available in the store and these are the apps that are on your machine. So it's a great marketing method for actually getting your apps promoted based on the devices. Also very, very easy to use customer experience. We can also connect with these devices on background threads as well. So if we wanted to, a good example is smartwatches. If we wanted to periodically connect to a smartwatch and update toast notifications and emails and things like that, we can do it on a background thread. And as it says here, it takes up to 10 minutes. We can run it for up to 10 minutes, and then we dispose of the connection, and we can reopen the connection each time. To do that, you have to, again, ask permission from the user to allow you to register a background process in your app, exactly the same as if you were doing any other background process, media, audio, all that kind of stuff. But it's a new thing that we didn't have before. We never used to be able to access devices from background threads, and now we can. The only one you can't do is obviously cameras, because that's a bit freaky of not accessing a camera without people knowing. But all these types of devices we can. The thing I forgot to mention as well, with USB devices, there are there's certain restrictions on what devices you can talk to. because the drivers are exposed in other ways. And the best way to explain this is you can't talk to a keyboard because Windows don't want you screwing up people's keyboards. Again, opening up to malware opportunities and things like that. On the HID namespace, they've restricted you accessing any device with a point of sale signature because they've written another API that allows you to do that. So when you're looking at integrating with devices, just check on MSDN to see what type of device it is and what best API there is to use it. Because there's always an API to access the device. You just need to make sure you're not saying, oh, I plugged it in via USB, so I'll go straight to a USB device, because it could be a POS or it could be a HID device, and just double check on the documentation beforehand. So I've talked a lot about consent. Consent's important. It's like we saw the whole fuss around the Xbox One thing of people think we're going to start sending everything to the government as soon as we plug a device into a machine. So the consent allows people to revoke that at any time, and we've got to make sure we deal with that. The other thing as well with revoking a device is another app can ask for access to it. So you don't get exclusive permission over your device just because you register it in the app manifest. Another app, and bearing in mind you can run multiple modern apps now in 8.1, other apps can actually ask for permission before your app gets to it. And to be a good developer as well, we need to make sure we dispose of our app. So if our app is suspended or is closed, we need to make sure we dispose of it properly, which I haven't done in any of my demos. So if I unplug a device or my tablet goes to sleep, the app automatically crashes because I haven't disposed of it, so it can't access the streams anymore, and it gets really, really confused. Also means that if someone fast switches between different apps, the other app can then take control of that device. So I can alt-tab between different modern apps, and I could have two different apps trying to control my Sphero. And it actually allows that because when the app is suspended in the background, it can disconnect and someone else can connect to it. I'm going to quickly flick through that slide. And okay, I touched on these APIs a lot last year because all APIs are fairly similar. But the device-oriented APIs, cameras, geolocation, I can't even remember them, I've done them so much, proximity, all that kind of stuff, they're all still there. I mentioned that at the beginning, but we just got a couple of extra ones added. So scanner, because I couldn't find a scanner or I didn't want to buy a scanner really to bring here and actually show you how it works, I've just put a little bit of scanner code up there. You go in and you go to windows.media.capture.scanner or whatever the namespace is, you get a scanner object and you say, I want to find a scanner, and it comes back with an enumeration and you say, yeah, scanner number 1, and you just say scan files to folder, and it will actually just go and connect to the scanner and start capturing information for you. No dealing with Twain drivers, no weird third-party APIs or controls. Nice and easy, and a good experience. There's actually a scanner app baked into 8.1 as well. It's called Scan, so it's there, and there's examples of it. But these device APIs are great, very, very easy to use. I've got one example just to show you, and this will be my last demo, and then I'll stop talking. And this is geofencing. I always push the wrong button. So geofencing is a new API. I've very briefly touched on it, but this is the ability for you to register an app with a specific geolocation or geopolygon, I think the term is, so a boundary, and you can say as soon as someone enters that boundary, do something, or if someone leaves a boundary, do something. So that can be a point, it can be a circle, it can be a town, it can be a school. And it's an interesting API because we actually hand all this back to the operating system. So the operating system keeps an eye on what you're doing, where you are, and it just raises events to you. So you don't need to worry about running background threads and stuff that actually look at location. The operating system's doing it, and it's doing it for you in a power conservative way. I've heard a lot of people ask for this, and I was shocked to actually see it appear because I didn't think it would be something we would be getting so quickly just because of how power intensive it's actually going to be. I just downloaded the sample app, so dev.windows.com. There's a whole load of other samples around all the device APIs. Just because, again, I spent so much time figuring out robot arms and stuff, this one wasn't as interesting for me to play around with, but I thought I'd show it to you anyway because it has quite a lot of uses. Like a lot of unis have asked for this. Like you walk onto a campus and you can say, hey, welcome to such and such a uni. This is the map and things like that. You leave campus, it closes the app, you don't need it no more. Or you go onto different uni campuses and it contextually knows where you are and it can say, well, you're now on East Campus, these are the new details, this is the new map. You don't actually have to specifically tell them where you are, and you don't have to have light on the map, it just knows and it's aware of that. So this is all the code that's required to actually create a geofence. So very, very similar to the geolocation stuff we went through last year. All lives in the same namespace. It's just an extension of that existing namespace. So what we're going to do is create a collection of points, which makes a polygon, as we all know if we've done SVG and XAML and all that kind of stuff before, and we get this region. We registered a collection with the namespace, and then we just get events. It's very, very easy API. It's an event-driven API. The region has changed, and you get an argument pass, which is an enumeration. You can do this in the foreground. You can also do this on background thread. So there's a background thread that's been, a new background process that's been added called geolocation. And you'll see that in the app manifest now. So if I open this up, in the declarations, you'll see location has now been added into the app manifest so we can start to do location-based background processes as well. If I run the demo, I can go geofence, I can create my geofence, and it throws an exception. That's great for register background task. Okay, demo's not working, so that was a good way to finish the session. Okay, if you're interested in geofencing, come and find me in the dev den today or tomorrow, and I'll sit and go through it with you. It's a really interesting API, and it has a whole load of uses, but people do get very confused around it. The reason I'm speaking very fast is because I think I'm running out of time. Back on the slides. Okay, just a quick summary. The ecosystem of apps. We had a whole great run last year. I'd done 25 sessions or so over the course of 12 months talking to people about how they can integrate with the devices that are built into this, the camera, the geolocation, the NFC, the audio stuff. There's a whole load of things, all the sensors, the motion bits and pieces, a whole load of stuff we could have done and a whole load of stuff people have done. They've built some great games and augmented reality apps and stuff like that. A year on, I actually saw some of the leaked Blue SDKs, and I kind of fell in love with the stuff that we were seeing. We had all of this USB stuff added. We had all the point of sale stuff added. We had 3D printing added. And I went over to build, and it was true. We've come a long way in a year. Like, it's insane how far the devices guys have come, but it means that we've opened up this ecosystem of apps. So that now means all of these devices that you have in your house that we previously couldn't talk to, all these devices you had in your enterprise we previously didn't talk to, we can do it, and we can do it very, very easy in a very, very managed way. So I've shown you some bits. I've shown you Bluetooth 2, Bluetooth 4, USB, HID. I think there's 15 new specific API device namespaces. Covers a whole breadth of apps that I haven't even been able to talk about. So very, very easy APIs, very, very easy ecosystem of apps to start building with. So for the Ramirez family, back to them, we actually did this philosophy of a connected home, connected experiences. It's coming true. We're going to start to see it more and more apps. Hopefully next year I'll be able to come back to you. We'll have more APIs, but we'll have a whole load of different experiences. I actually forgot the big TV demo. After the AV guys spent all this time hooking up on big TV. Sorry, I know you guys are desperate for lunch and things like that. This one's actually really, really impressive if I can get it working. So, I haven't touched on the proximity stack. I'm going to do that tomorrow on Windows Phone. So proximity, NFC, Bluetooth, Wi-Fi Direct, and things like that. One of the new features of Windows 8.1 is Wi-Fi Direct namespace. So we can start talking to two Wi-Fi devices on a peer-to-peer style basis. We can do that in either two ways, with Wi-Fi Direct or a new standard called Miracast, or as Intel like to call it because they invented it, a wireless display. What that means is I can actually buy a little black box and plug it into HDMI via a TV. I can then actually go into my Charms bar and go project to. This is going to be interesting to see if it disconnects. And it starts searching, and over Wi-Fi wireless display, it will come up with that push-to TV device. That's now a second display. I can hook into it, and it most probably won't connect because I've had issues with the wireless in here not allowing me to do it. But what that will actually mean is I can now connect using Wi-Fi Direct into a display and have absolutely no cables on my tablet or on my Ultrabook. Great if you're an enterprise and you want wireless meeting rooms. You can walk in, connect to a projector, done, sorted, easy. Or if you're like me, I have it on my TV at home, and I can start streaming movies to it because it's a HDMI wireless connection via Wi-Fi Direct. Very, very cool technology. It's an $89 adapter. They're available on JB Hi-Fi. You just go and buy them. They also work on Android, so if you have a Samsung Galaxy and stuff like that, they stream all the content off a Samsung Galaxy. I actually wanted to do my whole demo on this, and I actually wanted to walk around the stage and just work here and things like that. Unfortunately, I can't connect to it, which is really frustrating because these guys took half an hour to try and get that TV set up for me. Okay, back to slides. I think that's my last slide, and I think I'm open for questions. You can win a mouse, apparently. Some more resources, and they've taken my other slide with links out. But any questions from anyone? This is a wireless display device, so it's its own access point. It's a Netgear push-to TV device. The model number is PDV3000. But yeah, Wi-Fi Direct, it actually takes the USB power from the TV and it's just HDMI, so it's completely self-contained. Yes? Blogs, Kickstarter. It's the best place to be buying devices at the moment. All of the startups are going to Indiegogo or Kickstarter, and it's normally the smaller US companies that have the apps and the APIs and stuff. They're the guys that have got their mind in open source, so they're building the hardware and then open source and the APIs. So a Kickstarter, I also use PSFK, which is it's actually an advertising website, but they normally have a lot of the new gadgets and stuff that are appearing as well. But then also you just generally like TechCrunch, The Verge, stuff like that. Normally anything decent will appear on them as well. Or follow me on Twitter because I normally buy the stuff and it posts on my Kickstarter wall, on my Twitter stream. Yes?
Are most of these APIs available for Windows Phone as well? Or?
I'll talk about that tomorrow. Come to my session. The API story on Windows Phone is different. So yeah, I'll talk about it tomorrow or come and find me at lunch and we'll have a chat about it. Any more questions? Okay, guys, thank you for coming.